and electric motorbike development facility and a former lecturer in University of Moratuwa, as well as who has a background of automobile engineering from Australia. And further, he has a past record with Formula student, Team Shark and Falcony Racing of University of Moratuwa, and good colleague of mine. And he's a good person to talk the topic electric vehicle. Is it a solution for the fuel crisis in Sri Lanka these days? And he's in the business and he's the person, a best person to talk about it. So with that, I would like to invite Mr. Sasiranga to take over and have the presentation. In the meantime, we can accommodate the other guests. Over to you, Sasiranga.
Okay, thank you, Dr. JR, for the introduction. Let me try and share my screen. Is the screen visible now? Or?
Yes, good and clear.
Yeah.
All right. Shall I start, or are we going to wait for a while? Or?
We can start, Sasiranga, until the others will join.
Okay. Anyway, I wanted to keep this short and sweet, and as I explained to you, I prefer to have discussions or Q&A sessions a little longer than me just doing the presentation. So as Dr. JR introduced, my name is Hasiranga D. Silva. I'm the founder and CEO of Thermalar Industries Private Limited. We are into sustainable energy and transportation. We develop products and services. At the moment, mainly focusing on electric mobility, but we have some IoT-based products and also energy storage devices and other industrial products like 3D printers, which are all made locally. Anyway, jumping into the topic today, that is electric vehicles as a solution for the fuel crisis. Now, when Dr. JR asked me for a topic, I said, this is a sort of a current affair, and since we're into electric vehicle manufacturing, I thought, we'll pick up this topic since the fuel crisis is here and people are quite worried about the rising fuel prices and the lack of fuel in fuel stations and all these issues that we are facing, again fueled by the economic crisis that is going on in Sri Lanka. So the topic is electric vehicles as solution for the fuel crisis. So before we start, let's see what an electric vehicle is. Now, obviously, we all know there are a number of definitions to this, but the most simplest one that I prefer to say is an electric vehicle is a vehicle propelled by a motor. So the propulsion system, basically the one that spins the wheel, is a motor. The energy source, depending on the energy source, there can be different variants of it, but the most popular one is the one with a battery. So batteries with different chemistries are there. We have lithium ion, lithium perophosphate, we have nickel cadmium, nickel metal hydride, so many different lithium polymer batteries, so many different chemistries that are going into when defining an electric vehicle. So many energy batteries that comes in different kind of chemistries like that. But the core is this has to be driven by a motor. Now, if you look at a fuel cell car, that is also an electric vehicle, right? Only the energy source is different than from a basic electric car that we know. Instead of having a lithium ion or a solid state energy storage device, we have a liquid stage or compressed air. Compressed hydrogen as the energy storage in a fuel cell vehicle. But still, there is also an electric vehicle. So by definition, a vehicle that is driven by propelled by a motor. So why is it so important? Why did this become a very hot topic in the recent past? One is the depletion of crude oil that we all know, and if you read research papers on this and all these published articles about how long the existing crude oil reserves are going to last, you'll find different number of years mentioned in these articles and research papers. Some say it's going to last for 30 years, some say 40 to 50 years, some even predict, like there are conspiracy theories that predict that it will last much longer than that, maybe up to about 60, 70 years. But either way, what we know for sure is that the crude oil reserves are going to end one day. And of course, we have this, and then again, when something becomes scarce, its value becomes higher. And we can see that quite recently. I mean, it's not a scenario that affected Sri Lanka, just Sri Lanka. Some European countries were affected far worse than us. The rising fuel prices, of course, hit quite bad some of the European countries and all the other countries in the world likewise. Because, of course, we know fuel is become a scarcity in the future, and we can only expect the fuel prices to go up. And then we have the problem of global warming. With this, I mean, transportation industry sector is a major contributor to the global greenhouse gas emissions, mainly due to the combustion engine vehicles. Now we are slowly transitioning, but still we have a large number of cars driven slowly by engines. So they directly, I mean, the combustion process directly produce carbon dioxide and carbon monoxides and other, nitrous oxides and gases that directly contribute to creating this layer of greenhouse gases on top of the atmosphere, which increase the global temperature slowly. So that is another thing that we have to deal with. And addressed by introducing, let's say, starting off with hybrids to plug-in hybrids to transitioning into electric vehicles, fully electric vehicles in the future. Statistics, we can see the demand has been growing, and the number, particularly in certain countries, particularly in developed countries, we can see the growth is much higher. And these are some statistics that I've taken from IEA, or the International Energy Agency, and the statistics plotted by Statista. And you can see from the graph, you can see China in yellow, Europe light blue, and United States in dark blue. China, you can see the growth from 20. If you look at 2019 to 2020, obviously the Corona time period, there's not much of a growth. But if you compare 2020 to 21, you can see the numbers have, I mean, obviously more than doubled. And if you look at Europe, it has almost doubled. And United States, the EV numbers have almost tripled. So there is a very rapid growth, and you can see if this continues soon, pretty soon, I think we'll see a lot of electric vehicles on the roads, and I think the number of EVs on the road will surely exceed the number of petrol vehicles in the near future if this pattern keeps to continue. So there's a huge demand, as you can see from the statistics from these countries. And if you compare these markets like United States, Europe, and China with the rest of the countries, the growth, the other countries only accounts for a smaller portion actually. So Asian countries are a little far behind in this electric way, in introducing these electric vehicles to the market, but we are slowly getting there. And Sri Lanka is also, I feel that we are a little progressive now in introducing electric vehicles, especially with this economic crisis and the fuel crisis that we have faced. Government is trying to introduce policies and trying to promote electric vehicle manufacturing also in Sri Lanka. So hopefully there will be a brighter future for EVs in Sri Lanka as well. Now, when we talk about EVs, as I said, of course, it has gained popularity for the major reasons that we have shown here. So these are factors that all the general public knows about. But in an engineering perspective, if we compare an electric vehicle with a combustion engine, right? Why do we say an electric vehicle is more efficient, or it's more suitable? Can be more validated to address the current issues of fuel crisis, and also can be a really good candidate in terms of energy efficiency. Why do we say that? Now, if you look at this graph, I'm guessing that all of you are from a mechanical engineering background, so I have these certain terminologies that we usually use in mechanical engineering, and also especially in automobile engineering. So I'm going to use a couple of terminologies. One is the brake-specific fuel consumption. Brake-specific fuel consumption is basically the amount of fuel that we have to burn in an engine under ideal scenarios, right, standard scenarios, to generate a kilowatt hour of energy, right? the petrol or diesel that we have to burn to generate a unit of energy, 1 kilowatt hour energy. Now, when you do a dynamometer testing and if you get the specific fuel consumption versus power or torque graph, it generally follows something like what I have shown on the right hand side in this slide. The graph, if you look at it, the bottom line is the specific fuel consumption line, and the torque line, I'm not very sure if you can see my arrow. The torque line is the one that starts from about 100 and slowly, rapidly increases and then slowly flattens out. That is a torque graph. And the power curve is the one that sort of like this sort of a tangential kind of a graph that rapidly keeps on rising to about 5,500 rpm and then slowly flattens out. Now, in general, what we understand is when the specific fuel consumption is lowest, we get the maximum torque out of an engine. That is generally the torque curve is highest, and sort of flattens out where you get the lowest specific fuel consumption. That is where the maximum, the highest efficiency that we get out of an engine. It produces the maximum amount of torque using little amount of petrol, right? So that generally for a normal engine, it falls somewhere between 2,000 to 3,000 RPM. And as the RPM increases, the specific fuel consumption suffers. That's why, when you drive it like a race car, you burn a lot of fuel. As you can see, when the RPM rises, if you look at the 5,000, 6,000 RPMs, you can see the specific fuel consumption is much higher. That means you need to burn more fuel to generate the same amount of energy. Now, that is how that is the basically the relationship between specific fuel consumption versus torque and power. Lower the specific fuel consumption, generally the higher the torque, okay, and better for the engine to operate in that area to be efficient. And the other thing is, if you are particularly talking about petrol cars, we have throttling, right? So basically, throttling again reduces the overall efficiency. So throttling is like basically like when you breathe, if you say obstruct your nose, like say you put your finger over your nose like this and try to breathe, you have to put more effort, because now you have to your lungs have to do more work to get the air in, right? Because there's an obstruction to your air ducts. So just like that, in a petrol engine, when there's a throttle, right, and if the throttle is closed, of course there can be no flow. I mean, there can be a little tiny bit of flow. And if the throttle is partly open, there's an obstruction for the airflow. That means the engine has to do more work to get the air in. And only when the throttle valve is fully open, there is no obstruction for the airflow, and the engine will be doing less work to get the air in. So, but in practical scenarios, when you drive your petrol car, how many times do you get to press the accelerator pedal all the way down? That means full throttle. You hardly get to press the accelerator pedal all the way down, right? You are always accelerating like quarter or maybe 50% is a rare case. So you always have an obstruction to the airflow. That means basically generally the engine has to do additional work just to sack that air against the throttle position. Now, if you look at this graph, you can see the top graph has plotted RPM on the x-axis and brake horsepower on the y-axis. And you can see if it's quarter throttle, that means the accelerator pedal is slightly pressed, right, at low speeds, let's say. As the RPM increases, the brake horsepower decreases, as you'd expect, because you need more air to be in the engine to be burned with fuel to generate more horsepower, and at quarter throttle you cannot gather much air, right? And on full throttle, as we expected, you can see as RPM increases, you can see a rise in brake horsepower because you get enough air inside the engine and you can put more fuel and burn it and get more power out of it. Now, if you look at the specific fuel consumption in these scenarios, in the bottom graph, you can see again RPM on the x-axis and y-axis is specific fuel consumption. You can see at quarter throttle, you can see the specific fuel consumption after about 3,000 RPM, it greatly suffers, right? That means if you're driving your car slowly with your accelerator pedal pressed slightly, as the speed increases, you will be burning a lot of fuel to generate the same amount of energy. And if you look at the full throttle graph right here, it's sort of flat. That is where you get the sort of lowest amount of specific fuel consumption number throughout the RPM range. It's sort of flat. So that is the ideal scenario for you to run the vehicle with saving fuel, because in your full throttle you can see the amount of energy, I mean amount of fuel that you need to burn to generate the same amount of energy, that is 1 kilowatt hour, is far less. So this is how the throttling scenario relates to specific fuel consumption, or how much of fuel that you need to use for you to propel the vehicle. And the other factor is the load. Now you can see the same thing. You have the engine RPM on the x-axis and the load factor in y-axis. Load is basically how much of work that you are getting out of your engine. So basically, let's say it's a 100 kilowatt engine with a say 50 Newton meter max peak torque. Unless you are getting all that out of the engine, it is not running at its full load. If it's a car, let's say if we design a car to carry 5 passengers and 100 kilograms in the boot, unless you are carrying 5 passengers and 100 kilograms in the boot, you're not applying the full load to the car. Okay. Now, according to this graph, you can see the specific fuel consumption is lowest at its full load, that is 100% load. Okay. And as you can see, at 25% load, the specific fuel consumption is very high, and as the RPM increases, it drastically drops. And then again, at about 2000, after 3000 RPM, it rises again. But either way, that graph stays far above the 100% load graph. So basically, a 25 load scenario would be a driver and a passenger. Maybe, two passengers would be like a 25 load percentage scenario, load carrying scenario. So most of the drive, when we are driving our gasoline cars, we have a driver, just the driver driving the car. So single person driving the car. That will be a very low load scenario. Maybe a driver and a passenger will be there somewhere. That will be quite similar to a 25% load scenario, right? So we are not even applying the full load that the engine is capable of carrying. So again, in a real life scenario, we are at somewhere around 25% load, and the throttling is also maybe about quarter throttle. So we are basically not getting the best out of these engines when you are driving around. That is why generally the petrol engines are said to be 15 to 25% efficient. I mean, this is 25%, of course, you get at high maximum load, maximum throttle. In an actual driving scenario of a car, real life scenario of a car, you will be operating somewhere from 15 to 25%, 15 to 20%. About 20% is also rare case for a petrol car. And a diesel car actually can reach about 40% maximum. That is again at a full load scenario. Now in diesel engines, of course, you don't have the throttle valve. So diesel engines don't have that obstruction to the airflow. So it can basically suck all the air in with natural aspiration. And also sometimes you need a bit of boosting where you have to install a supercharger or a turbocharger for a diesel car. But the throttling effect, I mean, throttle valve is not there in diesels. So basically, if you set a diesel engine to run at its full load, it can be far more efficient than a petrol engine, and it can reach for about 40%. Now that is the engine's efficiency, petrol and diesel. Now, if you look at an average motor, its efficiency ranges from 85 to 90%. So if you supply electricity to it and get the energy in that electricity and calculate how much of mechanical work is being done by that motor, then efficiency comes for about 85 to 90%. It can be more or less depending on the type of motor. So you can see motors as a propulsion mechanism is for a car is far more efficient than a petrol engine. But then the question people ask is, where do you get this electricity from? Now, obviously, if it comes from a renewable energy source, then of course the overall efficiency of an electric vehicle is far higher than a petrol car. It's very obvious from these values. But we don't, like, none of the countries are fully sustainable. Generate the electricity from fully sustainable resources, right? Now, if you look at Sri Lanka, most countries do not solely generate electricity using crude oil. Now, because of that, I mean, because of that, of course, obviously, most of the countries, they have a portion of electricity generated by renewable energy sources. So the overall efficiency still becomes higher than burning fuel in a petrol car. Now, in Sri Lanka, we have about 30% contribution from renewable sources. It can vary from based on the rainy seasons, but generally it comes to about 30%, and the portion accounts for the renewable energy portion is contributed by solar, hydro, wind, and biomass. And then, of course, the other comes in from diesel and coal power generation. And the other thing is, in an automobile application, you can see I have said 40% is the maximum, but again, the load scenario is there, especially for a diesel car vehicle. So rarely it will pass 30% efficiency margin because of the loading case, and also throttling also is, throttling not in terms of the throttle valve, but the injector scenario where the controlling of the injection level and how much of diesel is going into the engine is there. So basically, in mobility applications, engines hardly operate at its maximum efficiency. But in stationary power plants, right, even if you generate electricity using a stationary power plant and then supply that to an electric car, still the stationary power plant can always operate at its maximum capacity or efficiency because it's stationary. No throttling is needed. You can apply full load to it and start generating electricity, so the efficiency will be far higher. So that is the advantage of running a diesel generator to create electricity and running an electric car with it, because the overall efficiency will still be higher than simply burning diesel in a automobile application or an automobile engine. And Sri Lankan grid emission factor comes to 0.6925 kilograms CO2 equivalent per kilowatt hour. Basically, to generate a kilowatt hour of energy or 1 CEB unit of electricity, the Sri Lankan, all these electricity generation scenarios will produce 0.69 carbon dioxide equivalent kilograms. Okay, that is the Sri Lankan grid emission factor. So all these grid emission factors vary from country to country based on their energy sources that are being contributing to generate this electricity, grid electricity. Now, one thing that we can do based on this data to have a good understanding, now it's still a gray area, right? We don't know how much energy is actually being used to generate a kilowatt hour when the vehicle is an electric vehicle is driven, and also how much of actual energy and carbon dioxide is emitted in the whole process of creating a kilogram of petrol or diesel to be burned in an automobile engine. Not just burning in the automobile engine, but of course there's a process associated with refining crude oil and extracting crude oil. So there's a whole process that involves with bringing a kilogram of fuel to your vehicle, and also there's a process associated with generating a kilowatt hour of energy from the grid. So by only assessing the whole scenario, you get an idea about how efficient or how effective your electric vehicle is in terms of addressing the carbon dioxide emission factors or the energy efficiency. So there are different aspects to life cycle assessments. Life cycle assessment is basically the scenario that I explained, where you compare the two scenarios or the whole processes of two different processes, and analyze the effects, basically to analyze the energy consumption or the costs associated with it, costs associated with the processes, or maybe the emission. Now, I have done an LCA or a life cycle analysis to some of the products that we do at Thermal Industries. So we have the electric motorbike, we have the bicycle, and we have the electric three-wheel conversion. So I took this sample life cycle analysis calculation that I did for electric three-wheelers, where I compared the environmental impact of electric three-wheelers versus the conventional gasoline three-wheelers. Now, first of all, we have to identify the boundary and the scope, because if you look at the whole process of extracting crude oil to the point where it's refined and then being burned in the three-wheeler. That's a huge process where it's very it will consume a lot of time and resources to figure out all the values involved with it. So to reduce the efforts going into that and to have a justifiable result, we have to identify a scope. So in this process, I have identified the scope from refining the petroleum to transportation of petroleum to the stations or the filling stations to burning them in the gasoline tuk-tuk. That is the scope I have identified for the tuk-tuk, petroleum tuk-tuk. And then for the electric tuk-tuk, we have this boundary. Of course, the boundary comes from then, the production of electricity is where the scope starts from. But before that, we have the crude oil extraction, because, our grid electricity has diesel power generation, diesel electricity, coal in it. So that is one input going into production, and the other is coal. And then, of course, we have the renewable energy sources going into production of electricity in Sri Lanka. But for the scope, we have started from the production to generation of electricity to the end point, which is the consumption of electricity in the electric three-wheeler. And now we know the factor here, the production of electricity I showed you earlier, the emission factor is 0.69. Yeah. All right. And using those factors, we can basically do a small calculation and figure out what are the emissions involved with these two scenarios, driving a petrol three-wheeler versus an electric three-wheeler. Sorry. Yeah. Now, this is the calculation, so you don't have to, read through all. Just focus on the last two sentences. The CO2 emissions reduction per month per unit converted is 176 kilograms. Percentage reduction of CO2 emissions by converting gasoline three-wheelers to electric is 54%. So there's about 54% carbon dioxide emission reduced per three-wheeler converted, and also in kilograms, it's about 176 per month per tuk-tuk, okay, per three-wheeler. And then the cost saving, of course, the biggest factor. If you can do a same sort of a calculation to see what are the cost benefits of driving an electric three-wheeler versus a petrol three-wheeler. If a three-wheel driver does about 100 kilometers per day and taking the cost per liter as 110, when you do the calculation, the cost savings per month comes to about 42,000 rupees. That's a huge amount for a three-wheel driver. This cost saving as a percentage is 86%. So you can obviously see there's a large amount of money that can be saved by driving an electric car. For this, certain assumptions were made. The electricity, the cost per kilowatt hour is taken as 32 rupees, which is quite okay, I think. And then, of course, the new cost per petrol liter is 410. We have done the same thing for a motorbike, so don't worry about the calculations. Look at the last two sentences. If you do the same LCA for a motorbike, the CO2 emission kilograms reduction per month is 61 kilograms, and as a percentage, it is 54%. So there can be a large amount of CO2 reduction if you do a conversion from a three-wheeler to a electric, or a gasoline motorbike to a electric motorbike. And we have done this calculations were specifically done for Thermal-R products. This is the Thermal-R electric motorbike. It's called the Paragreen. This is a prototype that we have done, and we are planning on manufacturing number of units by the end of this year. And we have this electric bicycle. The motorbike is basically made in Sri Lanka. We developed the chassis, the body, electronics, most of the components. We have about 60% local value addition. The bicycle is basically converted into electric in Sri Lanka. And the three-wheeler, this is the electric three-wheeler that we build. Basically, this is converted into the conventional three-wheeler converted into electric. We basically take the engine and the surrounding systems out, and we install a motor, battery, coupling mechanisms, and mounting brackets, motor controllers, the digital display, etc. And basically it becomes a brand new sort of like a brand new powertrain fixed to a all three-wheeler. But the driving pleasure is there. The electric vehicle driving feel is there, just like when you're driving a Nissan Leaf. Okay, so basically these calculations are the practical data we take from the products that we already have, and other from the literature. For electric motorbikes, all right. Now, of course, if you take it as summary, the same things I have summarized here. Basically, emission savings come to about 54%. Cost savings comes to about 86, 89%. So basically, if you do these kind of calculations for a three-wheeler motorbike or anything of a small scale transportation mode, the emission savings will come to roughly about 50 to 60%. Cost savings most of the times say above 80%, unless if it's like a car, can be a little less. The bigger the vehicle, the cost savings can be a little less, but for smaller vehicles, the cost savings are much higher. I mean, from these values, it's quite obvious investing in electric vehicles would be the best decision you will make in terms of personal savings, because I personally saved a lot of money during the in some days, when we had these long queues, I left my car and I was riding my electric bicycle to work. I mean, my office is also near University of Moroto in Katubedda, and from here to there, and to come back, the round trip from my home to work and back is about 25 kilometers. And I just do a single charge for the bicycle. I go there and come back with a single charge, cover that 25 kilometers, and still a bit more juice left in the battery. And that only cost me, cost me about 0.36 CB units, right? Quite small. And if I do the calculation for the whole month, I'll be spending somewhere between 500 to 1,000 rupees to travel to work and back from my electric bicycle. Whereas if I drive my petrol car, I'll be spending about 25,000 roughly rupees on fuel alone. Okay, that's a huge saving, about 24,000 rupees a month just to go savings, just to go to work and back. So if you switch to electric vehicles, you have a lot of personal savings, and of course we'll be contributing to generate a healthier environment. And then of course the country's economy will grow. We are spending so much of money just to import fuel, and of course on personal savings, I had mentioned, of course, electric vehicles do not have this regular maintenance, so you save money on that as well. Now if you take your car to get your regular periodic maintenance done, you will be spending about 20,000 rupees to get your service done. If you do 4 services per year, or 5, you'll be spending about 80 to 100,000 rupees a month, a year. So there you can save on that as well. And there's a good trend in Sri Lanka to manufacture electric vehicles, and there's some good amount of government support in with respect to that. So focusing on electric vehicles will hopefully will develop a local industry, local manufacturing industry, and as I said, it will save money on fuel imports. So switching to electric vehicles at this time will be a really good decision by the Sri Lankan community if you make that decision for the following reasons that I just mentioned. Electric bicycle, again, as I mentioned, I have done this separate calculation on electric bicycle to tell you that how, electric bicycles are very convenient. Now, when I was using it, now for me to go to the supermarket close by and to get my small errands done, and buy these small items in the evening, to go to the bakery and buy the short eats and all that, I used to go by car, because the bakery and those supermarkets are about 1 to 2 kilometers away from where I stay. And I had to open the gate, reverse the car, and go there, and have to look around for parking in the evening, because at busy times the car park is full at the supermarket. So it's quite a hassle. Now when I was using the bicycle, it was very convenient. Just hop on the bicycle, ride it from here to the supermarket. The traffic is not a big issue, and parking is not an issue, right? It was very convenient. So even if you use it as a secondary transportation mode to do your errands, it's still very convenient, and also it will save you money. This small calculation was done to show you how effective electric bicycles are. If you replace your car with an electric bicycle, how much of money that you can save, how much of energy it will save for the country. So 200 watt electric bicycle, sorry, it's not a motorbike, it's a bicycle, will do about 25 kilometers, and the energy in the battery is, basically the battery is 10 ampere hours, and the voltage is 36. So in terms of watt hours, it's 360 watt hours. That is 0.36 CB units, right? Now I drive a Toyota Corolla, and its engine is about 80 kilowatts, right? 80 kilowatts is 80,000 watts of power, and it requires about 2 liters to do 25 kilometers. To do the same distance as my electric bike per charge, it requires 2 liters, right? And the gasoline calorific value is about 45,000 kilojoules per kilogram, and taking the density, and if you do the calculation, by burning 2 liters, it generates about 67,500 kilojoules of energy, right? And if you do the calculation, 1 kilowatt is 3,600 kilojoules, and if you do the calculation, that is about 19 CEB units, right? So bicycle will use about 0.36 CEB units in terms of energy, right? My Corolla will use about 19 CEB units to do the same distance, right? 25 kilometers. That is from me to go to work and come back. So you can see the vast energy gap. And of course, if you compare the cost, I told you about the cost, right? The electric bike will only use about 1,000 rupees per month for my transportation needs, and my car used about 25,000 rupees. So there's a huge saving on that. So emissions and running cost of bicycles can be considered comparatively negligible compared to a car. So if you have the chance to switch to an electric bicycle, now is the time. You can save money. You can contribute to, contribute in, towards creating a healthier environment. Then of course, with this rising or the prices of the consumer market, everything that we buy from supermarkets, so everything has basically gone up. So any sort of savings will kind of help to uplift your lifestyle. If you have children, you can better provide for the children. So basically, I think an average professional would spend about somewhere between 30 to 40,000 rupees a month on his or her vehicle, when considering all the expenses associated with the vehicle, right? If it's a petrol vehicle, like services and fuel, right? So you can basically save that money if you switch to an electric bicycle. If your travel distance is low, say somewhere between 20 to 30 kilometers, and if you only have to travel during morning hours and evening hours when there is no sun, like that's what I used to do, like we get to work by 8, so there is no sun, and when I leave work it's 5 o'clock, after 5, then there's no sun. So it's very convenient. Only thing is, riding a bicycle during the sunnier hours will be, can be a little hectic because of the the hot weather, and you might sweat. But if you're just going to work in the morning and coming back in the evening, electric bicycle will really suit your lifestyle. Now, how do this all adds up to being a solution for the fuel crisis? Now, of course, now you get an idea how much of money that we can save in terms of personal savings, but how much switching to electric vehicles, how much of money can the government or economy can save by switching our fleet into electric vehicles? Now, for this analysis, I've taken a small round trip, a small calculation. I have done a small calculation, taking a round trip of petrol car, of going a round trip of 50 kilometers, and another bicycle, electric bicycle, doing the same trip of 50 kilometers round trip. So I have averaged the fuel usage to be 4.3 to do 50 kilometers, and for the bike, I have taken 360 watt hours of electricity, which will consume, which will be about 14.4. When you do the calculation, sorry, it's 720 watt hours to do 50 kilometers. That was 360 for 25 kilometers, 720 watt hours for 50 kilometers. Okay. So petrol car will use 4.3 liters, electric bicycle will use 720 watt hours. And if you do the calculation, you get, and the assumptions were mentioned here. The assumptions that I made was cost per liter of petrol for the government. So just to generate a liter of petrol in the refineries and to produce that to the market, the government will spend 400 rupees. And to produce 1 kilowatt of energy, the CEBO, the electricity board, will require 20 rupees. So those are the assumptions that I've made. And the exchange rate is 360 LKR per USD. And taking those into account, and if you do the for a round trip of 50 kilometers per day, the costs for the government for the petrol involved is 1,720. For the electricity involved, 14.4. And if you do the calculation for the same, for the 100,000 units, imagine 100,000 cars. Obviously, we have more than 100,000 cars running on the roads. I think the number comes to about 500,000, somewhere between 300 to 500,000 cars. the cost for the government in rupees is this. And if you do the same calculation in USD for an entire year, the total expenses will come to about 174 million US dollars as an expense for the petrol. And for the electricity produced, the cost for the government comes to about 1.46 million US dollars. So if 100,000 people using cars switch to using bicycles, right? Switch, say, starts. These automobile users all of a sudden, decide to buy an electric bicycle and do their daily traveling, the government will roughly save about 173 million US dollars annually. And I've done the same calculation for an electric motorbike and for an electric three-wheel conversion. So if you do the same calculation, these for 100,000 units, bicycles, as I showed, you can save about, the government will save about 173 million US dollars from fuel imports. If a gasoline motorbike user switch to electric motorbike, again from fuel imports, you can save about 140 million US dollars. And if you do conversion of three-wheelers from gasoline to tuk-tuk, again, there will be a saving of about this. Now, this is for 100,000 units. Now, we know we have about 1.1 million three-wheelers on the road, and roughly about, I think, somewhere around 500,000 cars. And the largest fleet in Sri Lanka is motorbikes. And we have over 5 million motorbikes, right? 5 million motorbikes on the roads. And this calculation is for 100,000 motorbikes. Now, imagine if half the fleet converts into electric. And with these amounts of savings from fuel imports, the entire annual savings to the government will be in billions of dollars, right? About 10 billion for sure. Calculations can be easily done after this. But anyway, just to give you an idea, if we convert not even half, say quarter of the fleet into, once we promote these electric vehicles, and if we reach that point where at least quarter of the vehicles are electric, the savings on fuel import for the government will be in US dollar billions. Okay, that is how this introduction of electric vehicles can actually tackle the crisis that we are facing right now. So one is, it will eventually save money for the government. Two, the living standards of the people will increase because there will be more savings for the general consumer. And three, it will promote a local industry. We have a number of players who are into manufacturing electric vehicles, and that will encourage them. When the market develops for electric vehicles, then the demand is there. More players will come into the market. So basically, we have a huge potential moving towards electric vehicles, and a large portion of it will directly contribute into getting Sri Lanka off this economic crisis. That's it for my presentation. Thank you. And now we can move on to the Q&A session.
Thank you. Thank you very much, Sasranga. And the audience, if you have any questions, please, you can raise directly by opening up your mic. Or else you can put that on the chat so that I can speak out. Any questions from the audience? Questions, comments, or clarification? Yeah.
I'm Loshan Palangra, one of the IMECI members. Just wanted to ask you, because you were just comparing the four-wheeler and a bike, electric bike, throughout the presentation. So how do you see that our road, regulations and all may need to improve if these bikes are being, used in high numbers? So for the time being, we don't have any cycle lanes. We don't have any dedicated areas for cycling in not even in Colombo properly. So how do you look at in this way to implement this kind of a solution?
Yes, now there are a number of barriers, of course. So we as engineers, we are trying to do our part. So we are trying to promote electric vehicles and manufacture. Now UDA is actually the one who's responsible for allocating this. One authority that is responsible for this, allocating these certain lanes for buses and bicycles. So they're actually carrying out a project. I don't know how long it will take to implement. I've spoken to them also, and they have a plan to allocate bicycle lanes connecting some of the major routes in Colombo, connecting suburbs with the city. I'm not very sure how long it will take. Of course, it is necessary. When we start promoting electric bicycles, these things have to happen parallelly. there is this what you mentioned has been in discussion in most of the meetings that we have with the ministries, and the authority who's responsible is the Urban Development Authority in allocating these things, the cycle lanes, and they have a proper plan. I'm not very sure how long it will take to implement that. In certain areas, like in from Piliandal to University of Moratu, of course, we do have bicycle lanes, but we don't have much cyclists occupying these lanes. So that's why I said we need to have these things happening in parallel. Now, if you have allocated cycle lanes and they are empty, of course, nobody will really care about it, right? If you allocate cycle lanes and if you see a large number of cyclists using those lanes, then it'll become a norm and it'll get popular and people will put more attention to it. So that's why I said these things need to happen parallelly. But I mean, we are doing our part, of course, as engineers and manufacturers in producing these products. And of course, we are in touch and talking with the relevant authorities in creating the ecosystem. As you mentioned, like, you know, allocating cycle lanes, and especially for, let's say, electric motorbikes, allocating charging stations throughout Colombo. CEB also has a plan. So these things have to be done collectively with all the stakeholders combined together. So it's actually in talk. I'm not very sure. I can't give a straight answer how long UDA will take to execute that plan.
Ranga, I'm Lalvir Singh here. Thank you very much. It's a very good presentation, and this is the right presentation of the hour. With regard to your idea of three-wheeler conversion, and you said there's a lot of savings for the country as well as for the with regard to the energy. One thing I want to know is the RMB has given the approval to do the conversion. Now, once you do the conversion, do we have to go for another approval or another, what you call, get a license or something? Because when I checked with somebody, they said because the weight of the vehicle get reduced and you may have to re-weight and all kind of things. Because RMB is another place where a lot of restriction to get the approval. That's one question. The second question is on the same thing. Now, the most important thing is the battery. Is the government have ease out the restriction to import battery for these electric vehicles, or can we use the existing batteries what we have, locally manufactured batteries? Can we make use of those batteries to run these electric vehicles? Thank you.
Yes, okay. Now, for a long time, of course, there were some obstacles when it comes to registering converted electric three-wheelers, because there was no proper criteria or an assessment or, say, a regulatory document or anything for the RMV to actually assess. Some years back, somewhere in 2018, I was in one of those committees which we actually drafted a document that was, the committee was actually was a part of the Transport Commission, I think. It was called from that, and I was in that committee, and we actually drafted a document using international ISO standards for electric vehicles, vehicle powertrains, and we came up with documents saying that if you are converting a three-wheeler to electric, these are the things that you have to follow. But I don't think that actually reached RMV. I'm not very sure what happened, but we submitted that document to the Transport Commission, and after that, that was in 2018, 17 or 18, I'm not very sure. But that was done. But then after that, I'm not very sure if RMV received it or not. But a lot of people actually complained about this. And now, of course, during Corona, we were taking a small step back because we couldn't actually go and work. We are in mechanical industry, like manufacturing. We can't work from home. So from 2009, I think 19 till 21, I personally couldn't interact with RMV much, because I was actually pursuing one of the people who were pursuing these electric vehicle conversions and talking to RMV, figuring out a way to, get this done officially and to come up with the regulatory framework. And I was, of course, asking them what happened to the regulatory framework that we developed with the Transport Commission. So somehow I was in touch with RMV and we were trying to get this to work. Now that the government is also very keen on getting these electric three-wheel conversion done, now we again got together. I had a meeting with them a couple of weeks back also. And now there are a number of companies who have successfully done the conversions. And again, fueled by this fuel crisis, RMV is also very keen on getting the conversions done now. And I think by now, of course, some of our staff members after I left, I think Dr. Lihil took over, and he's also in one of these committees. And RMV, University of Moratuwa, and certain other parties in combination have come up with again a set of regulations, and I think that will be enforced pretty soon. I think it will be there as an official document by at least about December, in another 2 months' time. It will be there by with RMV, and they will have the proper criteria for the conversion of three-wheelers to electric. And by next year, anybody who has successfully done the conversion according to standards, who can comply with the document that is there at RMV, we will be able to commercially do it. And again, okay, you asked another question about the lithium-ion batteries. Okay, that question, I think there was small disturbance as I heard. Of course, lithium-ion batteries, one is what we can do here in Sri Lanka is, of course, we don't have lithium as a mineral here. We have to import the lithium-ion cells. We can manufacture the battery here. We can develop the electronics. We can build the housing and all that. I know there are some companies that are already into manufacturing of lithium-ion batteries here, even cells, but you have to, of course, get the raw material from outside. We have one of the major raw materials, which is graphite here, but that accounts for about, I think, 15 to 20% of the whole battery. So majority of the material we have to import. We can develop an industry, but the thing is, then of course, you have to have a proper recycling plan. The recycling of lithium-ion is not very easy. There's a huge investment. I've done a bit of studying into that. So the recycling plants will have a certain number of cells to be manufactured each month to cover the investment that are involved with it. So it's a little complex, but for the time being, what we can do is we can actually manufacture lithium-ion batteries here, battery packs here, but we'll still have to import the lithium-ion cells. And for recycling, there are companies actually that buy off the used batteries and send it back to certain companies in overseas companies, where they actually buy off the batteries for recycling.
Okay, thank you very much.
Thank you very much. Mr. Lolita, you have raised hand. Mr. Lolita.
You must be mute.
Yes, raised hand. Until such time, yeah. There is another question in the chat from Mr. Lianagi. Can you please talk about the time consumption comparison? I think he's referring to the travel duration by the cycle and versus a car or something like that. Time comparison.
Yes. Now, the electric bicycle, the Thermalar E250, that was the one that I was using to go to work. We call it E250 because of 250 watt motor. And that has a top speed of 30 kilometers per hour. Now, generally, when I travel from my place to work, that is in Katubedda, I mean, Nugegoda, Udhamulla to Katubedda, it takes about half an hour from the car, or more than that. If I get stuck in the traffic, it can be about 40 to 45 minutes. If I leave here around 7, then when the traffic is not there, it will be about half an hour. But either way, from the electric bicycle, it always took me less than 30 minutes to get to work from here to work, because the traffic wouldn't be much of a problem with an electric bicycle, and I took all the by roads easily. And the average speed was about, say, somewhere between 20 to 30. Sometimes I was able to go 30 kilometers per hour on the main roads, and it was sort of like the same time that it took me to go to work from home to work, of course. But if you're traveling, of course, intercity, like long distances, a car would be would work much faster, because the bicycle can only reach 30 kilometers per hour. Of course, for safety reasons, you can't increase the speed. I mean, we have a version that can go up to about 40 kilometers per hour, but that is the maximum we can allow for a bicycle to reach because of the safety factors. But for city driving, city traveling in traffic and basic driving conditions, a bicycle would work far better than a car. For long distance, of course, an electric motorbike would be more suitable.
Again, actually, I couldn't put my question. So basically, I have 3 questions. One is reliability, right? How we are going to benchmark the scooter reliability against conventional IC-driven motorbike? This is the first one. The second thing is the safety level. So in case of accident, So what is going to happen? What are the safety precautions you already taken during the designing and manufacturing? The third one is, so insurance. Are there any high premium to be paid because of this electricity connect, because of this modification? I think that Mr. Prashant and Nalin would help you, being insurance professionals. So those are 3 lines. I would like to get some response from you, Sasiranga. Thank you.
Okay, insurance, of course, it's going to be almost basically the same, because we have insured the electric motorbikes that we have built because we wanted to do road testing. So we needed to get a insurance done. So insurance is basically similar to that of a petrol car. So insurance will not change. In terms of safety, of course, basically one is when you build the electric vehicles, there are standards to assure safety, right?
Sasiranga, you got muted. You got muted.
Sound there.
Okay. Sorry. I was talking all this time. Okay. I guess you didn't hear. So basically about the insurance, now we had to insure the electric motorbike that we developed because we had to do road testings. So when we went to take the insurance, it was the premium that we had to pay was just as same as that what we would pay for a petrol motorbike. So the insurance didn't change. That was from the experience that I had with the motorbike. So insurance was same. You can maybe check with a Leaf car owner. I think that is also going to be the same. Insurance will not change, I guess. About the safety, of course, when we build electric vehicles, there are international standards, and if you follow standards now, we had this discussion with RMB also when they wanted to have people come with electric vehicles, modified vehicles, electric vehicles imported from different countries. So they wanted to have an idea of how to register them. So basically, the first thing that came to my mind was, okay, whatever you buy, whatever the car that they bring has to be built to standards, right? The company has to give a document assuring that these vehicles have been built according to SAE standards or ISO standards, Euro standards, something. So one is that if you follow standards, a lot of safety precautions are covered with that, just by following those standards. Okay. Then after that, the majority of the danger associated with an electric vehicle, okay, one will be the short circuit scenario where an electric the power cables can get short circuited to the body and someone might get electrocuted. Well, for that we have a number of safety features. So short circuit protection is that. So basically, if something happens, so a leakage happens to the chassis of a vehicle or motorbike, there's a feature where the motor control basically cuts off the power supply, and the BMS, battery management system, also cuts off the power supply if there's a short circuit happening to the chassis, right? So that is one example. So there are a number of safety features like that. And the other is, of course, the protection in the battery. Now, a battery, of course, has to be securely installed inside the chassis. Say, for example, when we build the motorbike, we carefully considered where to place the battery. One is it carries some amount of weight, so it has to be as low as possible to keep the center of gravity low and keep good handling of the motorbike. The other is, in an accident, the battery should not obviously project outside, so it has to be securely placed inside the chassis cage, just like an automobile engine. So if you follow those, the electric vehicle can be safer than an engine car, because fuel is highly ignitable, right? If a catastrophic accident happens, there is a more chance for the fuel to ignite than the battery to ignite. I mean, fuel ignites with a flame, battery does not really ignite with a flame. So the parameter that gets affected by this ignition of fuel versus electric battery is different. So if you carefully manufacture or design this electric vehicle, it is actually safer than the fuel powered vehicle, in my opinion. And the other question you asked was about the reliability. Reliability in terms of, now if you compare a basic car or a petrol vehicle or motorbike or a car with an electric motorbike or a vehicle, the only thing that changes is the powertrain, right? The suspension, brake, the chassis, body panels, the electronics, or most of the electronics are the same except for the powertrain. So the reliability, we have to compare. The reliability is a factor of the powertrain. So you're just comparing the electric powertrain versus petrol powertrain. And when you compare that, of course, petrol engines have evolved over time, very rigid, robust, so it will last long, no doubt about it. Electric vehicles are also, I mean, the motors have been tested for a while. If you buy a good motor from a supplier, it will of course last really long, at least about 10 to 15 years for sure. Only thing that you have to replace is the battery. Of course, battery has a certain number of cycles depending on the chemistry of the battery. A lithium-ion good quality battery will have about 2000 cycles. So in general usage, you will obviously have to change the battery in about 7 to 8 years time. But with the savings, of course, the return of investment with an electric car is much higher when compared to the fuel car. So the reliability cannot directly be compared, because obviously you have an expensive component you have to replace over time with an electric vehicle, which is a battery. But until that the battery wears out, right, until that 8 years, let's say you have 8 years to replace the battery, if the vehicle is properly designed and you have bought proper, like let's say A grade equipment, quality motors, controllers, and all the electronics were properly selected, of course they will last long as much as any other electronics or components that will last in a petrol car. So only the battery will have to be replaced.
Okay, thank you. Thank you very much, Sasiranga. Right.
Yeah, I think we are coming to closure, but one last question from the chat. Have you ever considered about including a regenerative braking system for electric bicycles? Regenerative brakes.
Yeah, now of course regenerative braking, I think all of you know about it. So basically it is you know, when a car slows down, let's say you're going down a hill, or when you're applying brakes, generally if it's a petrol car, say it's not a hybrid, just an engine car, what you do is you apply brakes. Of course then the brake pad will hit the brake disc and it will generate friction and it will create heat, and that is how you convert the kinetic energy into heat, and you know, slows down the car and bring it to a stop. But in an electric vehicle, you have in this potential, instead of hitting the brake pads all of, at once, you have the, I mean, if you're slowly braking, you can actually use the wheel or the kinetic energy to run the motor, and you know, motor will start generating electricity, and you can supply that energy or electricity to the battery and store it there in the battery, instead of applying brake pads and creating heat and, you know, just wasting that to the atmosphere. You can actually, with an electric car, you can actually generate electricity and store it in the battery in braking scenarios. If you're braking the car quite slowly, if it's rapid braking, of course the brake pads will come into play. But you're slowly braking, or if you're slowly going down a hill, the regenerative braking will apply, and it will generate electricity and so in the battery. So basically, if your vehicle has this regenerative braking function or not, a motor will anyway generate this electricity, right, when you're slowing down. So it's a matter of taking that electricity and supplying it to the battery, which actually saves that energy and gives the term regenerative braking. Okay. Otherwise, the motor will anyway, when you slow down, if the motor is driven, if the motor shaft is driven, it will anyway create electricity, right? Now, this grabbing this electricity from the motor and storing it in the battery is a function of the motor controller. So if your motor controller has the capacity to grab that spike of current, the thing is, when you brake and the motor all of a sudden start to create this electricity, you have a spike of current, and the motor controller needs to have the capacity to regulate and absorb that current and send it to the battery. So some motor controllers, like the good ones, have this function. So if you select the motor controller, it's a matter of doing the proper connections from the motor to the motor controller, and using the motor controller's regenerative braking function, it basically will send the energy back into the battery. So with all the products that we have at Thermal R, the motorbike, the electric three-wheel conversion, and also the electric bicycle, all three products have motor controllers with the regenerative braking function. So of course, to answer your question, we do have regenerative braking, but the regenerative braking is most effective, I would say, when the vehicle mass is higher, like a car, right? Then of course the kinetic energy is higher. Kinetic energy is a function of mass. So a car slowing down will generate a lot of energy and store it in the battery. But for a bicycle, I'm not very sure what sort of a percentage of energy can be recovered. Either way, the regenerative braking will accommodate for about, I think, maximum 5% of the overall energy consumed by the car. Like let's say if you have a car without regenerative braking and you can run for 100 kilometers, with regenerative braking it might go for about 105, something like that.
Right. I think our stipulated time comes to an end. I would like to thank on behalf of the IMEC Sri Lanka group and all the participants, Sasiranga, for giving us this opportunity and speaking out your experience and clearing out a lot of our doubts. Actually, Mr. Lal, the chair, is very interested in electric three-wheeler conversion as well. So we may talk later with him as well related to these things. And thanks again. Thanks for spending out your time in this evening to share your experience and thoughts with electric conversions and electric traveling. Right, I lost my power as well. Right, thank you very much.